Good morning, my viewers, and how's everything? Yeah, your son has come your way again today. Yeah, Oginni Ayoola, your online power academy facilitator. Last time in our lectures, we talked about calculation for fuse rating of where we understand some of these things. And thank you so much for as many people that have been inboxing me and be doing the class work. So today, quickly, we'll be talking about the percentage loading of a transformer. You know, I told us that transformer, you can't actually know whether transformer is overloaded or not unless you check, unless you do some calculations. You know what I'm saying? And your calculations start from using this our equipment, call it clamp ohmmeter. So what you do? The first thing is you can't judge if that transformer is overloaded. You can't judge by facial look. You can only go there to the secondary side of your transformer. You know, when we're calculating our fuse rating, we work on the primary side, which is the level side. But for percentage loading, which is the load side, you go and check. You know, we have 3 phase and 1 neutral. You go there, you put your clamp ohmmeter on the amperage like this. You see it, you put it there. So once you put it on the amperage, you clamp phase A, you get the reading. Phase B, you get the reading. Phase C, you get the reading. So what you do is you add the 3 together and divide it by 3. So that is the average reading of that transformer. After then, you know what each of your transformer is carrying per phase. The maximum load, you know, 500 kVA, we know the maximum load 696. For 300 kVA, we know the maximum load 417 amps. And for 200 and the rest, I'll teach you the calculation today, how you can know what each phase is carrying per phase. So once you know it, you just do it, what the average loading on that transformer, divide by the total loading per phase of that transformer, that particular transformer, multiply by 100. So you know by the percentage loading of that transformer, whether it is 80%, 50%, or thereabout, then you know it's overloaded or not. So let's just go to our calculation part of the system. Calculating the percentage loading of the transformer, you start from you knowing the percentage, the load per phase of every transformer. Now look at our question now. Percentage loading of a 500 kV, 11 kV slash 0.41. We will still use the same formula we use for our fuse rating, but this time it's on the secondary side. Now you see what I wrote, P is equal to IV root 3, where our P is equal to P, if our I is going to be what? P over V root 3, where our P is the capacity of the transformer, 500 kV. Is 0.4 is what is the primary side voltage of that transformer. You know, in those days we use 0.415, but these days now we use 0.400. I will speak to that someday. So now, when we are using on our nameplate, you see 0.400 kV. You use it here. Multiply our root. When you do all your calculation per phase of a 500 kV transformer, to be giving you 721 amps per each phase. Phase 1, 720. So that is the maximum a phase of a transformer of 500 kV can give you. In those days, when we are using 415, change the 0.415, you see when I do multiply, give me 696. Let me do for the 300 kVA transformer, and then we move on. So you can see the calculation for the 300 kVA on our board. Percentage loading, that we are still doing. But what I said earlier is, for you to calculate the percentage loading, you need to know the phase amperage per phase amperage per each phase of the transformer. So we have done for 500. I'm doing for 300 right now. So for 300 now to calculate, you still use a formula for fuse rating. So meaning for 300 kV. So I use for my primary side 0.400 kV. That's what we're using now. For 415 in those days, I still do that one too. So divided by 0. So this is what it's giving me now. So per phase of my 300 kV, the maximum it can produce is 0.433 amps. Why if you use 415, it's going to give you 417. Are we good to go now? We're now going to our percentage loading properly now of a transformer. So just follow. So now, since we understand how to calculate the load per phase, maximum load a phase can produce in a transformer for 500 kVA, we said it is 722 amps per phase, red phase 722, yellow phase 722. So each phase can give us 722. For 300, we know per phase can give us 433 amps. So you can calculate as well for 200 kV or 50 kV. So since you know now, we'll now go to our percentage loading properly now. So look at the formula I wrote now. Say for 500 kV, I said now the question is red phase 300. When you use a clamp meter to check, the red phase is 433 amps, yellow phase 503 amps, this one blue phase 423 amps. So you do your calculation, you add the three together and divide it by 3. Neutral, you don't work about it with the neutral. Neutral is negligible, you forget about the neutral. You add the 3 phase together, when you add it together, you give us 1364. You divide it by 3. Once divided by 3, it gives us what I wrote here. It gives us 458 amps. When you divide it by 3. So this is average load. All of them can produce. Then now with the percentage load, the width is what? The average load, which is your here, all over per phase of the transformer. I told you 500 kVA can give us 722. For 300 kVA, 433, and you calculate for the rest. So now, multiply by divided by 722, which is per phase of 500 kVA transformer, percentage multiply by 100. So meaning this transformer you are seeing here is going to be what? 63% loading. So it's not overloaded. So let me do for 300 kVA as well, and then I will now give us the class work. Are you following? Welcome back to our class. So calculation for 300 kVA is what you are seeing on the board here. You can see percentage for 300 kVA here. These are question 128 amps, 203 amps, 210 amps. You can see it. So now what we are not saying is you add the 3 together, divided by 3. It's give you 541. Divided by 3, 108 amps. So now then, and let's say, okay, my percentage, my calculation here, average reading for here, divided by what I put what. Now, 433 is what? Is the phase. Is the load per phase of 300 kVA transformer. I told us from the calculation you can get for the 200 kVA, for even one MVA. So now, when I do my calculation, it gives me 433 percentage load per phase of 300 kVA transformer. Multiply. So this transformer now is giving what? 46% loading. So it's not overloaded as well. So now when the transformer is getting to 75% loading, start thinking about relief. Start thinking about other things to do, whether you're operating or maybe you're relieving that transformer. So I think we've been able to learn something today. So now I'll give us the classwork and you share it with me after you finish. I told us learning is sweet and learning is give us confidence. Just look at the classwork and let us just go ahead. Thank you. I've come to the classwork. So classwork is for us to just learn more. I will employ us to just go through the classwork, reply me, and let us just learn. So you can see it now. I said, what is the load per phase of the following transformer? The load per phase is the way we calculated the other time. For 500 kVA, 11415, 0.415. 500 kVA, 33, 0.400. 200 kVA, 11/400. And now say calculate the percentage loading of this transformer. This is question 1. 50 kVA, 33, 400. Red phase 40, yellow phase 52, blue phase 38. Why for this one? So 200 kVA transformer. So we do this one. So I just want you to just check it. And just, I'm expecting a reply very soon. So I think we'll be able to learn something today. And I'm hoping to hear from us soon. So our next class will be treating another thing again. Thank you so much. I want to appreciate the many people that are chatting, that are commenting, that are sharing it. Thank you so much for your advice, for everything. So we'll see you in the other class. Bye for now.